now guys, we have worked with graphs a little bit when we did those worksheets, all right, those small worksheets. Sometimes we gave you a graph, you had to interpret it. Oops. Sometimes we gave you information, you had to put it onto a graph. Okay, we're basically carrying on with those kinds of things, but we're going to formalize it quite a bit. So we're working towards where we actually give you an equation of something and you must draw it on the graph, all right? On a Cartesian plane, we call it, which is an x-axis and a y-axis. You guys told me you've done some of that in physics already, okay? But we're going to formalize it all. All right, so just as a starting point, let's just write this down. You can use a graph to describe a relationship between two quantities. If I'm thinking back to one of those exercises that we did before, it was a shoe size one. Do you guys remember? Where they listed, I think it was Jane or something, her shoe size as she was getting older. All right, so that graph, when we then actually plotted those values, that graph described the relationship between her age and her shoe size. Okay, so are we understanding the two quantities thing? All right, yes.
So it's not just two quantities, it's like two types of like she's 12 and then her shoe size is 6 or whatever.
Yeah, so it could also be one person is, you'll see it's lots of different types of scenarios. Okay, so eventually we're going to move on to not kind of real life situations like those ones where we have a shoe size and an age. We're going to move on to the relationship between X and Y. Okay, that's what we are moving towards. Basically the relationship between an input value and an output value. Now guys, where did we work with input values and output values before? Does anyone remember? Yes. With flow diagrams. Do you guys remember that? All right, we started with an input value, then we had stuff happening to that input value, and what we got out was obviously the output value. And guys, you remember that we then used flow diagrams as a way of solving equations, right? So all of those things are kind of interlinked. All right, functions. A function is something that describes a relationship between two quantities. All right, it was the same with an input value. Something is happening, it's giving us an output value, then an equation, and then also these real world kind of examples. Okay, now if we are looking at page 254, this is now something that I'm not going to redraw. Okay, so we have it there. They're saying, for example, this graph shows what happens to the temperature of a hot drink when left standing for 5 minutes. Now, guys, what do we think? What do we know happens to a hot drink when you leave it standing for 5 minutes? It cools down, hey? So as time passes, what happens to the temperature? The temperature decreases. All right, are we understanding the relationship between two quantities, two things, time and temperature in this case? Okay, so here you can see on the y-axis, we're going to talk a lot about which axis is x and which one is y tomorrow, so don't worry about that now. But on this axis, the y-axis, we have temperature. On the x-axis, this one, we have time in minutes. And we can see that at the beginning, right, when the drink is just being made, the temperature is 90 degrees Celsius. After 1 minute, we can see that it has decreased to approximately, I would say it's kind of just above 70. All right. After 2 minutes, it is now, what is that? That's like 58, maybe 57, something around there. All right. So we can figure out exactly how the temperature of this drink decreased by reading values off of the graph. Okay. Then they have some information here at the bottom. They're saying the graph represents the relationship between the temperature of the drink and the time that passes. You can you can see that as time passes, the drink gets cooler. All right, we've discussed that already. And is that clear to everyone, guys? You can see here, obviously, as we're going along the x-axis here, this bottom axis, the time is obviously passing because we're going from 0 minutes to 1, 2, 3, 4, 5. Right, so time is passing, and as that is happening, the temperature of the drink is decreasing, right? It's going down. Okay. The quantities that are plotted on a graph are called variables. You must have worked with this in, is it physics, bio, both? Okay, all right. In mathematics, a variable is a number or quantity that varies or changes. I mean, it is that in all cases, not only in maths. So the temperature and time values that you see in this graph are variables. Now, guys, this is what we're going to write down. This is going to be the first part of the note. This is important, and you have already worked with it, but let's write it down. The difference between a dependent variable and an independent variable. Okay, so I'm just going to write that down. Let's see if I have a better one. Okay, a dependent variable, that is the one that is affected by the other one, right? And I just added the word usually there because in the textbook they said it is the variable that you are observing, all right? Usually it's, yeah, depends on the scenario. So in this example where we have the temperature and the time, do we all understand that as time passes, the drink gets cooler, right? So time actually affects what happens to the temperature. Does that make sense? Right? So in our example, the dependent variable was the temperature. All right, that is the thing that's changing as time is passing. Okay. Now that is very important, guys. This part in blue, which is why I put it in blue, this variable always goes on the y-axis. Okay, and the y-axis is the vertical one. Like I said, we're going to talk a lot about x-axis, y-axis, the difference between the two. But that is the most important thing. If you are given two sets of information, and they are telling you just to draw a graph, and they didn't tell you which one must go on the vertical axis and which one on the horizontal axis. You need to figure out which one is dependent on the other one. Okay, and the one that is dependent, that is affected by the other one, has to always go on the vertical axis, the y-axis. Yes.
So the independent variable will be the time you leave it to stand, and the dependent variable will be the temperature.
Yes. Yeah, because the temperature changes based on how long you are leaving it to stand. Yes. Okay, so now it might make more sense when we write down the definition of the independent variable. So an independent variable Okay, guys, so an independent variable is the one that is not affected by the other variable. It's usually the one that you are manipulating. That second sentence, I think, is more applicable to something like science, where often when you're doing an experiment, you manipulate the temperature so that something, I don't know, so that a gas would form or whatever. I can't remember those experiments anymore. In this case, I mean, you can't really manipulate time. Okay, so that's why I just added the word there. Usually the variable that you manipulate, time just passes, no matter what you're doing, okay? But do we understand that time, or the way that time passes, doesn't depend on what the temperature of the drink is? Right? Does that make sense? So whether your drink is 100 degrees Celsius or 0 degrees Celsius, time is still going to pass. All right, the temperature of the drink has no effect on the time that is passing, actually. It's the time that's passing that is affecting the temperature of the drink. Okay, so that is why time, and usually, guys, in the maths questions, maths type of scenarios, time will be the independent variable. Okay, if time is at play, then you can know straight away that that will be independent, because we can't manipulate time. Okay. This variable always goes on the x-axis, which is the horizontal one. So you will see that whenever we are working with ones that have to do with time, that time will always be on the x-axis. Okay, are there any questions at this point, guys? Can we look at some more examples? All right. Here they are just talking about some more terminology. All right, so they're saying a graph in which the dependent variable stays constant while the independent variable changes is said to show a constant relationship. Guys, you remember with that shoe size one? Once she reached a certain age, her shoe size stayed 6. Can't remember what the age was now. All right, but in that case, regardless of how much time is passing, regardless of her age, her shoe size stayed constant. All right, it stayed the same. So we would then literally call that a constant relationship. Okay, if they're asking you for the name of that. Here we have just an example. All right, so this is where we have all these dots. This is exactly like that shoe size one. Okay, it carried on going up, 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 and then once she reached a certain age, it was just constant. Then they're saying we can identify other features of the relationship between the variables by just looking at the graph. The graph below shows the relationship between the height of a ball thrown into the air and time. Again, guys, do we notice that time is on the x-axis? All right, because time is going to pass regardless of what you're doing. The height of the ball is what changes. All right, if we just think we're throwing a ball into the air, it reaches its maximum point, and then will it stay there? It comes back down, hey? So do we see that that is literally what's happening on this graph? So at the beginning, the ball is here in your hand, then you throw it up. As time passes, it goes up, 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 and right there, that is the maximum point. In further years from grade 10 onwards, we are going to call this a turning point. Okay, does that make sense? Because it's actually, it's literally turning. The graph is literally turning there. But for now, we'll just call it a maximum point. And guys, if they're asking you for the maximum point, it's not a trick question. You are going to look at your graph. Where is the highest point on the graph? That is going to be the maximum point. Okay. You can see that the ball goes higher, reaches a maximum point, which is a height, and then drops lower until it falls to the ground. And that will then obviously be the minimum point. All right. What is the minimum point here? At 0, when it's back in your hand. Okay. When you release it, right before, and then at the end of the time when you catch it again. This graph below shows the cost of bottles of cool drink. All right, now this one is maybe a bit more difficult to figure out which is dependent and independent. Let's just talk about it. Bottles of cool drink, you have 0, 1, 2, 3, 4, and then cost of cool drinks. Guys, does it make sense that if you are buying more bottles, the cost is going to be higher? Right? If you're buying less bottles of cool drink, the cost is going to be less. So does it make sense that the number of bottles of cool drink affects the cost, right? The cost is the one that is being affected by the number of bottles that you're buying. Okay, so cost is the dependent variable because this one is affected by how many bottles you buy, and the bottles of cool drink is the independent variable. Okay. The first dot represents the cost of 1 bottle. The second dot represents the cost of 2 bottles, and so on. Now, this is an important point, guys. Why are the dots separate and not joined? Because if we're looking at this previous graph, it's a line, hey? If there were dots there, they're all joined. Here we have separate dots. Can anyone tell me why you think we have separate dots for this graph where we're talking about bottles of cool drink? Rebecca, do you want to try? Yes, they don't have meaning, right? Can you buy 1.5 bottles of cool drink? Hey? No, you go to the shop, you buy 2 bottles of Coke or you buy 3. You can't buy 2.5, right? So the spaces in between these dots don't actually have meaning if we're looking at the specific scenario. Okay, correct. This one, all of these values would have meaning because, guys, is the ball going to jump from your hand and then all of a sudden it's 1 meter above your hand and then it's 2 meters above your hand? It goes at a constant rate, I suppose. It moves up and then it moves back down. Okay, so these are 2 types of graphs. We call this one where all the values are connected, the dots, the points are connected. We call this a continuous graph. We are going to write that down now. And this one where we have separate dots because there's no actual meaning in between, at the in-between values. We call this a discrete graph. Okay, ETE, the spelling is slightly different. So let's write that down quickly. Okay, so discrete like that, it's not discrete like the other meaning of the word. Okay, any questions at this point, guys? We're just going to look at an example and then you're going to do a few on your own. Okay, I'm just going to write here C example on page 256 because I'm not going to write it down. I'm not going to copy the graph. But if you want to look back at it, it is on that page. But it's quite simple. I don't think you guys will need to look back at it, but we'll see. Right, guys, this is the example. They're saying this graph shows the rainfall over the last 7 days in Cape Town. Okay, it is quite small there, but there they have some dots plotted. Now guys, if we can just look at this graph straight away, we can see that the dots are not joined by any kind of curve or line. So we can see straight away that this is a discrete graph. Okay. Identify these features. A, the dependent variable. Remember guys, the dependent variable always goes on the y-axis and the independent variable on the x-axis. All right. So if we're looking at that, the dependent variable is rainfall. Okay. And does that make sense, guys? If we just, even if we forgot that, the dependent one is on y and the independent on x, you can still figure it out if you're looking at the actual scenario. Okay. The days are going to pass, whether it's raining or not. Right? Does that make sense? So the fact of whether it's raining has no effect on what day of the week it is. Okay. But the day, they're saying here time in days, that's a bit misleading. I actually would have preferred if it was like Monday, Tuesday, Wednesday, Thursday, Friday, right? Like that, but it's fine. So the day that we have actually influences what the rainfall is. Okay. So the dependent variable is rainfall in millimeters. For B, they're asking for the independent variable, that is time, days. All right, that one there. For C, they want the maximum value. So now, guys, you're going to have to look at all of your points and just write down the maximum one, the highest one. Okay, it really is as easy as it sounds. So that would be the highest point, and that is at 15 millimeters. Okay, so you identify the maximum point, the highest one, then you need to write down what that point actually represents. It's 15 millimeters. Okay, that is the maximum point. The minimum value, 2 millimeters. Hey, that's lowest point on this graph. The minimum value is 2 millimeters. Okay, and number 2, is the graph continuous or discrete? We've actually already discussed that. It's separate points, so it is discrete. Okay, any questions, guys? I think that's simple enough. I want you guys to do exercise 23.1. Unfortunately, it starts here, the graph is here, and then all the questions are on the next page. So maybe you can just take a picture of this graph quickly, and then I'll put the next page on so that you can answer if you don't have your books. Just make sure that you can actually see those points. They're not very clear. If you want to rather come take a picture from my textbook or from someone else's textbook, you can do that as well if it will be clearer. Okay. 256. It's exercise 23.1. All right, they're asking you questions about number 1. There we have A to F. Then there's a number 2, and there's a number 3 underneath that. I want to do all of them. It will go very quickly, guys. You saw now how quickly it goes in this example. Okay, so get going, please.